We have a warm-up problem. No words. That must be real math. Okay, so it's asking for d squared over dx squared. What does that mean? Second derivative. Cosine of 2x, e to the 3x. And we have options A, B, C, D, or E. I won't read them all out loud, but has anybody found an answer? What? D? B? A? It's D. It's D. Okay, so what do you need to do? Well, if you're going to take two derivatives, probably you should take one derivative at a time. It's not so obvious how to jump straight to the second derivative. Now, some of these you can almost guess how we kind of made you think like, oh, I'll take two derivatives of cosine would be negative 4 cosine 2x, and two derivatives of e to the 3x would be 9 e to the 3x, and negative 4 times 9 is negative 36. So like, oh, okay. So that might be an error that students might make. And you notice that we tend to put common errors as options. So it's good to be methodical. So anyways, no big surprises, I hope. You take the first derivative, use the product rule, and a little bit of chain rule, because you have 2's and 3's on the inside, so 2's and 3's come out. Then you plug that back into the derivative. The first term, again, product rule. Second term, product rule. And you get some combining. So you end up with 5 cosine 2x e to the 3x minus 12 sine 2x e to the 3x. All right, excellent. Okay, so our thought for today. All right. A nice, fun idea. I must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration. I will face my fear. I will permit it to pass over me and through me. And when it has gone past, I will turn the inner eye to see its path. Where the fear has gone, there will be nothing. Only I will remain. Does anybody know where this is from?
I do. Frank Herbert.
Yeah. Well, Frank Herbert, yes. Good. And it's from Dune. Why this quote? Why today? And well, it's exam season. And with exam season tends to come lots of anxiety, fear, and nervousness. Lots of stress. And in some sense, this is very natural. But it can also be highly counterproductive. When the fear, the anxiety, the stress overwhelms you to the point where it's hurting your studying, it's hurting your preparation, it can really damage the outcome. So you have to learn to deal with stress. This is a big part of college. It's a big part of life. And so what do we need to do? Well, one thing is we have to recognize that, yes, you will be nervous. You will get to the exam room. You will probably be nervous. You have to learn to relax. Breathe in, breathe out, be calm. Now, part of this, doing well, in getting to that point where you're calm, is building up your confidence. That's your preparation. The time that you've invested up to this point in the semester has helped prepare you. It will help you to be confident. With confidence, you'll be less nervous. And I know it's easy to say, just don't be nervous. And I'm not saying that it's as easy as flipping a switch. But I can tell you that learning to deal with your emotions can have tremendous positive outcomes on your performance. Okay. All right. Well, with that thought, let's get to what are we doing? Well, essentially, we're at the point where we have a whole bunch of rules. And we have two categories for rules. One is we have particular functions for which we know the derivatives. So essentially, x to a power, e to the x, and your trig functions. And you also have rules for combining things. Now, some rules are so ingrained into us, sometimes we even forget to say them out loud. But this basically says that, derivatives break up over addition. So if I have a bunch of things being added together, take the derivative of each little piece. Similar, if I have a constant, I can pull it out of the derivative. You have the product rule, which tells you how to handle when you multiply two functions together. And of course, you can generalize that to more than two functions if you want. You have the quotient rule, which is the lose a point rule. Because a lot of people forget, is it f prime of x, g of x? Or is it f of x, g prime of x that goes first? So whatever you need to do to remember, do that. You can always do the quotient rule by other means. In particular, you can always get it by combining the product rule and the chain rule. The most important rule is the chain rule, because most functions are written by putting functions sort of stacked up one inside of the other. So the derivative of f of g of x is f prime of g of x times g prime of x. So know your rules. Important for this exam? Yes. Much more important for the exams to come. And not just for this class, pretty much any class in the future where you're going to have calculus involved, you need to know these rules. Maybe you don't have to stress too much about the quotient rule, but everything else, that should become so second nature to you that you do it automatically. And so most of the work right now is knowing your rules, knowing what order to apply them. Don't try to be creative. Just think about what's my current layer of my onion. I talk about onion problems. There's layers. Do that layer, move on to the next one. All right. So let's try some problems, and my plan is we'll work through them together. We'll start with this one. We're given that y equals 4x minus 6 is tangent to the function y equals f of x at x equals 2. And we're asked to find tangent lines to y equals f of x squared and y equals f of x. All right. Now the first thing before we get too far here is to remember that when we talk about a tangent line, and I'll say 2h of x at x equals a. I just want to be very generic here. What I'm really saying is I know two things. I have two pieces of information. Namely, what is the value of the function at a? What's the value of the derivative at a? So having a tangent line is just as good as having those two pieces of information. Having those two pieces of information is just as good as having a tangent line. So most problems can often be phrased as, I have a tangent line. Let me go to my pieces of information I have. Let me use those, and then I might go back to a tangent line. So let's practice going from a tangent line to information. So this first part, y equals 4x minus 6 is tangent to y equals f of x at x equals 2. That should tell us something about f of 2 and f prime of 2. So what is f of 2? And how do we know that? F of 2 is 2, correct. How do we know that? You plug 2 into the line. So 2 times 4 minus 6, 8 minus 6 is 2. What is f prime of 2? 4. How did you know that? It's the slope. Now, somebody else said, you took the derivative. And actually, both are right. But for right now, we'll probably say, we took the slope. Wink, wink. Secretly, it's the derivative. Okay, so we can say, look, really, this first statement is just telling you this information. Okay, so now we're asked to find tangent lines. So we say, okay, we're going to find some tangent lines. So let's work through these. So here, let's start with this one. Y equals f of x squared. Well, we need to know some information. What information do we need? So find tangent lines. I didn't say I should add at x equals 2. I forgot to add that when I wrote the problem. So at x equals 2, what can we say about this? Well, let's call, for a second here, we'll call it g of x, this f of x squared. What is g of 2? And how do we know it? Four? How do you know it? Because you plug 2 in. G of 2 is f of 2 squared. So that's 2 squared, which is 4. All right, how about g prime of 2? Well, for that, let's focus on g prime of x for a second. What is g prime of x? So, I'm sorry, can you say it one more time?
2 times f of x times f prime of x.
2 times f of x times... Now, the way you're saying it, I feel like I have to write a question mark at the end because you're like, times f prime of x? Do I need a question mark, or is that really it?
No.
That's it. You're right. No question mark needed. Okay, you are correct. It's 2 f of x, f prime of x. Why? What's the rule? Chain rule. So you have... The outside function is a power. So when you say, oh, I have something to a power, the power goes down. So that's where that 2 came from. The inside stays alone. So this really f of x is really f of x to the 2 minus 1. So usually we don't write that f of x to the 1. But that's really what it is. It's f of x to the 2 minus 1. And then the chain rule says put a derivative there. Okay, so g prime of 2. Well, we plug in 2. 2 f of 2, f prime of 2. Do we know these things? Yeah, 2 times 4, 16. All right, so we know g of 2, we know g prime of 2. Is that enough for a tangent line? Yes. Okay, so tangent line. Here we go. We have y minus the y value. Which one of these is our y value? The 4. Equals our slope, 16, x minus 2. And that's a perfectly fine answer. Or if you like, you can rearrange this and say this is y equals 16x minus 32 plus 4 is minus 28. If you like to put it all together. Both are fine. All right. Are we done? No, this is the problem so nice. We get to do things twice. Okay. So let's say, all right, here we go. Similar idea. We're at x equals 2. We'll work our way through our alphabet. H of x is this f of x. So, what is f of 2? What is h of 2? H of 2 is f of 2. Now you got to go, you work out from the inside. But what is f of 2? So this is secretly f of 2. But what is f of 2? 2. So h of 2 is 2. Ah. Well, that was kind of convenient. What is h prime of x? F prime of f of x times f prime of x. What rule was that? Chain rule. Okay, so h prime of 2. That's f prime of f of 2 times f prime of 2. Well, f of 2 is 2, so that's f prime of 2 times f prime of 2, which gives us 16. Now, it's a coincidence that these were the same. But mostly this is just practice, doing things. So, similar, y minus the y value, slope 16, x minus x value. So it's very similar, not exactly the same. All right, so y equals 16x minus 30. Okay. All right. Are we good?
Where did the f of f2, where did the first f go? Or did it just kind of like cancel each other out or something?
Well, it's not that, because we knew f of 2 was 2. So this inner part, this f of 2 became a 2. So it's f of 2. So it wasn't that there was cancellation. It was just like, this is just works out very, very nice.
So then, if it was like, if it became 3, for example, we make that, we just do the whole equation again.
Well, if it was f of 3, we'd have to have more information. Because right now, the only information we have about f is at 2. So this one is like, I'm giving you very, very specific information. Because the tangent line only gives you information about where you're tangent. So if I have my tangent line at 2, what can I say about what happens at 3? Nothing! I have no clue. But you're saying, but 2 and 3 are so close. No, they're complete strangers. They don't know each other. They're far apart. So the only chance we have is if we know things work at 2. But we could always have a problem that gives us a lot more information. And then it's always a matter of, okay, there's a lot of information. What's the right information to use? And we'll have problems like that, assuming we go at a good enough pace. All right? Cool. Okay, so tangent line means we have information about the function and the derivative. Now, we might have information given to us in different ways. We may not have an explicit function. We may have a picture. So let f of x be the following function. It's a picture. And we have some points, 0, 0, 2, 4, 6, 2, 8, 4. And these curves are actually straight line segments. All right. We're told that h of x is f of 2x cubed f of x, and we're asked to find h prime of 1. All right. Good. Well, how do we start? Well, we want to plug in 1. Are we ready to plug 1 in yet? Why not? Why aren't we ready to plug 1 in? Because we don't have the derivative. We can only plug 1 in once we have the derivative. So how do we do this? Well, let's take a derivative. Okay, so we're going to take the derivative here of h of x. What rules do we need? Yeah. We need the product rule and the chain rule. Now, which one's going to come first? What's our outermost rule? The chain rule. So because we have this function with this inside part, and it's the inside part that's the product rule. So h prime of x is the derivative of the outside is the derivative of the outside. It's f prime. We leave the inside alone. Leave it alone. Times. All right, what comes next? Product rule for the inside. So, I remember my product rule, everybody gets a turn. The derivative of 2x cubed, 6x squared. And what happens to this f of x? Stays the same at this point. And now, it's not 2x cubed's turn anymore. So it stays the same, times f prime. All right, so we have now been tested on our rules. So, okay, so great. So now we have h prime of x. What do we do? Now we have a place where we can plug in 1. So h prime of 1 will be equal to f prime of 2 times 1 cubed times f of 1 times 6 times 1 squared times f of 1 plus 2 times 1 cubed times f prime of 1. Okay, so let's see if we can't clean any of these things up. It looks like we have some f of 1s and f prime of 1. So let's come to our diagram. 1 happens to be between 0 and 2. True story. What is the value of the function at 1? Can we figure that out? 2. How did you figure that out? Well, we see that there's a slope here of 2, right? A rise of 4, run of 2. So there's a slope of 2. If I start at 0, I move over by 1. To have a slope of 2, I have to move up by 2. Okay, so f of 1 is 2. So we can replace this f of 1 by 2. We can replace this f of 1 by 2. Is there anything else we can replace? F prime of 1. What will that be? F prime of 1 is 2. But I'm going to use a different color here. Why am I using a different color? Because that 2 is different from that 2. This 2 comes from the value of the function. Where does this 2 come from? The slope of the line. And the punchline is, well, what's the tangent line? It's just like if you kept extending it. So this line segment can be extended into a line, and we have our tangent line. Okay, so we update. So moving upwards, we have f prime, 2 times 1 cubed times 2, 4. 6 times 1 times 2, 12. 2 times 1 times 2, 4. All right. So what's the next thing we have to figure out? Okay, I can tell you 12 plus 4 is 16. But there is another thing we have to figure out. We need to find f prime of 4. So what do? We come to 4. We say, okay, it's up here. And you're like, great. So I see it's at height 3. Is f prime of 4 3? No. Well, what is f prime of 4 then? How do you find it? Yeah. If I was looking for f of 4 is 3. F prime of 4, you think of it as the slope of the line segment. Because that line segment can be extended to a line, and that line would be the tangent line. So, 2, 4 to 6, 2. So you go down by 2 over 4. What slope goes down 2 over 4? Negative a half. Right? Or negative 2/4, if you will. Rise is negative 2, run is positive 4. So, what do we get? We end up with our answer, negative 8. This was from an exam from a few years ago. See, we can do these problems. We're exam solvers. Wow, look at us solving exam problems. Which, by the way, in case you're wondering, wait, the back of the handout seems like that we don't have all the problems. Well, that's because on the back of the last time's handout, we ran out of space. So this is the continuation from last time. So that just shows you how much they love the chain rule. The chain rule is so much, we couldn't fit it on one page, all the problems. Wow. Chain rule. It's the best rule. All right. Let's see. Okay. Find the following. And do not simplify. Should we do it as a group, or do you want to do it and then we can come back together? Group? So we're doing it together? Okay. Well, let's talk about the first one. Let's think about our rules. What's our first layer here? quotient rule. Now, we'll remember a couple things. The derivative of sine? Or is it negative cosine? Positive cosine, good. Will you need to do anything else when you take the derivative of this term? Chain rule. So what will happen with that? So 3 will come out in front. Derivative of e to the 2x? E to the 2x times 2. Chain rule. Derivative of x squared? 2x. And notice the plus. That says just take that derivative, and add them together. Okay, so are we ready? We'll write down one swoop. Our favorite problems say do not simplify because we don't have to simplify. So we start low, which is the denominator, d high, derivative of sine 3x. I just remember that I'm going to have a 3 coming out, so I leave some space in the front. So the 3 is from the chain rule. So far, so good. Low, d high. Minus high, d low. Derivative of e to the 2x, we mentioned. 2e to the 2x. Derivative of x squared is 2x. We're just adding them up. Is there anything else? Yeah, all over the denominator squared. And now, is there anything else? Nope, that's it. We put a box. Nice big box. Yes?
How come you kept the 2 in the exponent with the e?
Because if you remember the chain rule, why is there still a 2 up here? The chain rule says f prime of g of x. So the inside function never changes. So the 2x is the inside function. So this 2x stays as the inside function. And so that won't change. And it's just you're adding the derivative of the inside function to it. Anything else for that part? We have a second part, don't worry. Oh, this will be cool. Let's quickly dispense of this last piece. The derivative of e to the 3 pi. 0, why? It's a constant. It's a funny looking constant, but it's a constant. All right. What's our first layer here? It's going to be a product rule. Now, this first part, no worries. This second part, we actually have some layers. How many layers do we have for chain rule? Yeah, it depends what you count as a layer, right? It's a function, inside a function, inside a function. What's the innermost function? The t squared. T squared is inside what function? Secant. But what does the secant squared mean? It really means you're inside a square function. So secant squared or t squared really says I have the function t squared inside of the function secant inside of a square function. This square root of t, we should probably rewrite it to make it calculus friendly. What's the calculus way to write square root of t? T to the 1/2, because that's our rule. Okay, so we're just rewriting, and we're allowed to rewrite things as long as they're equivalent. Why do we rewrite things? Because it makes it easier. That's why. Now, if it doesn't make it easier, you probably shouldn't be doing it. But all right, here we go. So, derivative of t to the 1/2 is what? Someone is doing it all the way, 1 over 2 squared t. But for us, let's just remember, power comes down, so this 1/2 comes down. And then it's t to the what power? Minus 1/2. 1/2 minus 1. Okay, and now we took the derivative of the first part, so the second part we leave alone. We can write it in either way, it doesn't matter. So I'll write it as I've written it here. Plus t to the 1/2, Now let's start working our way through these layers. First layer, what happens? The outermost layer is the square function. So what happens? The 2 comes down. So we have 2. Then secant t squared to the 1. So I'm doing, that's my f prime of g of x. Yeah? 2, function on the inside stays the same, and then the exponent goes down by 1. Okay, now we're working our way through our layers. What's going to come next? We're going to take the derivative of this part, the derivative of secant t squared. Okay, so the outside function now is secant. What's the derivative of secant? Secant tangent. So secant tangent. What goes? T squared. All right. Now, are we done? If not, what comes here? 2t. Now, do I need one 2t or do I need two 2t's? Just one. Because this secant tangent is just a single function. It's not two functions, it's a single function called secant tangent. Okay, and now what? Yeah, box. Someone said circle, but I don't think there's enough space to circle. So we'll have to box it. All right, we're good? Okay, how are we doing on time? We've got time, plenty of time. Plenty of time. Okay, here's a problem. Let f of x equal 1 plus e to the 5x times cosine x if x is less than or equal to 0. And then we'll have 2 minus ax over 3x squared plus x plus 1 if x is greater than 0. Answer the following questions and use limits to justify your answer. Ooh, cool. Okay, question A, is f of x continuous at x equals 0? Now, looking ahead, question B asks, for what value is f of x differentiable at x equals 0? So we already know the answer to question A, because it's trying to make it differentiable. If it's differentiable, what must be true? It's got to be continuous. You cannot be differentiable if you're not continuous. So we could say the answer for A is must be true, otherwise B is a silly question, but we probably want to get full points for that. Okay, so let's assume that that's not what they want. So how do you know if something is continuous? The limits from both sides have to match, and technically they have to match the value of the function. Now, because the value of the function is one of the two sides, we just need to check the limits from both sides. Okay, so part A says, hey, let's check these limits from both sides. So we're going to go from 0 from below, and we're going to look at 0 from above. Okay. I did not plan well, but that's okay. Limit as x approaches 0 from below. If I'm approaching from below, what do I look like?
1 plus top part.
The top part, because that's below 0. So 1 plus e to the 5x cosine x. If I'm approaching 0 from above, well, I probably look like the other part. This 2 minus ax over 3x squared plus x plus 1. Now, how do we take such limits? Well, you do what you do with every limit. The first thing you always do with every limit is to do what? You always plug it in. You never do anything until you plug it in first. Now, if you plug it in, what's the only time you have to do more work? Like 0 over 0. There's some other times, infinity minus infinity, whatever. But 0 over 0 means more work. But if you get a number, you're done. So you plug in 0. What do you get? 1 plus e to the 0. 1 cosine 0. 1, put it all together. 2, because it's 1 plus 1 times 1, right? Now, same thing over here. Put in 0. What do you get? Upstairs? 2, because a times 0 is going to be 0. Doesn't matter what a is. Downstairs? 1. And 2 over 1? 2. So, continue. So, yes, continuous. And the justification is the limits matching. Okay, so that's part A. All right, part B. For what value of A is f of x differentiable at x equals 0? Okay, so how do we know if something's differentiable when we have a piecewise function? Given that we already know it's continuous, what needs to be true? The derivatives have to match. The derivatives have to match. Good. So let's talk about our derivatives. When you have a piecewise function, you get piecewise derivatives. So let's look at f prime of x. What's the derivative of 1 plus e to the 5x cosine x? Well, it'll be 0 plus 5 e to the 5x cosine x. All right. And anything else? Minus, there is some other stuff. E to the 5x sine x. Why is there a minus here? Because the derivative of cosine is negative sine. All right. And this is if x is negative. Okay, now we take this derivative and we're like, Now, don't actually make the noise out loud during the exam, but it's okay to be like thinking it. It's a mental, and then you're just like, all right, whatever. We embrace it. Okay, so quotient rule, take the bottom. 3x squared plus x plus 1 times the root of the top, which is minus a, plus the top, 2 minus ax, times the root of the bottom. Oh, sorry, not plus, minus. Excuse me, minus the top, times the root of the bottom, which is 6x plus 1, all over 3x squared plus x plus 1 squared. And that's if x is positive. Okay, so that's your derivative. So, what do we need to do now? Keeping in mind, we need to use limits to justify. Yeah, you do the same idea. We need these to match. So we're going to look at the limit as x approaches 0 from below of f prime of x. That has to match the limit as x approaches 0 from above of f prime of x. And we'll just use what we wrote down here. When we come in from below, plug in 0, what comes out? Sine of 0? 0. That goes away. Cosine of 0? 1. E to the 0? 1. So we get 5. F prime of 0. So we're not going to simplify. We'll just plug in 0. 0 plus 0 plus 1. 1. Times negative a. Subtract. 2 minus 0. 2. 0 plus 1. 1. Divide by 0 plus 0 plus 1 squared. 1. So, those have to be equal. So that tells us, oh, we have 5 has to equal minus a minus 2. So what happens? We can move stuff around. A should equal, A equals negative 7. All right. So this is, yes, there's practice with the chain rule a bit here. but it's also just sort of reminding us of all the things we can do. All right. I think we can do one more before we do our multiple choice. I think this was from an exam. Let h of x equal f of g of x minus x squared plus g of 2x f of x. Find the tangent line to h of x at x equals 2 given the following. So now we don't have the function as a formula. We don't have the function as a picture. We have data. And that's okay. It's one of our favorite characters from Star Trek. So what do we do? How do we use this? Well, we start figuring things out. Now, if we're after the tangent line, we talked about this before, what are we really seeking? What information do we want? If I want the tangent line, I need what pieces of information? Yeah, function of 2, h prime of 2. That's what we're really after in this problem. Let's start with h of 2. So, plug in 2. h of 2 is f of g of 2, subtract 2 squared, plus g of 2 times 2 times f of 2. Now, what did we do? Everywhere we saw an x, we put 2. All right, what is g of 2? According to our table.
7.
7, right? We can look up, here's x equals 2, here's g. So g of 2 is 7. 7 minus 4, also known as? 3. So this first part becomes f of 3. Do we know what f of 3 is? 5. Yes? It's in our table. There's 3, there's f, there's 5. So this first part is 5. Do we know what g of 4 is?
4.
4. Do we know what f of 2 is? Negative 2. So do we know what this last term is? Negative 8. 5 minus 8? Negative 3. So here we have our h of 2. So it's table lookup. You plug in x, you just keep peeling. All right. So what's the next thing to do? We need to find h prime of 2. And if we're going to find h prime of 2, what do we need? We need the h prime of x. Oh, this sounds like it's going to be long. But that's okay. We have 75 minutes. We don't need, all the time for... Some of the problems are quick. So, h prime of x is, start here. What's your rule? Your outermost layer. What rule do you need? Chain rule. So it's f prime g of x minus x squared times what? Times what? G prime of x minus 2x. Very good. So the root of the outside, inside stays as is, times the root of the inside. What rule do you need for the back side?
No.
Well, you'll need a little bit of product rule, but the main thing to start with is, a little bit of chain rule, main thing is product rule. So the root of the first term, the 2 will come out, g prime of 2x, f of x, plus g of 2x, f prime of x. So it's testing our rules. At least it's testing our patience. Okay, now what do we do? Plug in 2. So h prime of 2 and f prime of g of 2 minus 2 squared, g prime of 2 minus 2 times 2, plus 2 g prime of 2 times 2 times f of 2, g of 2 times 2 times f prime of 2. Well, we've already done g of 2 minus 2 squared. We figured that out up here. G of 2 minus 2 squared was 3. Do we know what f prime of 3 is? f prime of 3 is negative 2. How about g prime of 2? Do we know that? G prime of 2? 5. 5 minus 4, also known as 1. Okay, plus, we have a 2. This term is g prime of 4. G prime of 4? 2. Then this says f of 2, which is negative 2. And then here we have g of 4. G of 4? 4. Times f prime of 2, which is 3. So we have minus 2, minus 8, plus 12, altogether 2. Oh, that's nice. It turned out to be not a bad number. Okay, so are we done? No. But the key is we've got the most important parts. We've got the information to make the line. So we make that line. So we say, okay, y minus which one of these numbers? The negative 3, because the negative 3 is the value of the function. So y minus the value of the function equals the derivative, slope, x minus 2. And that's a great answer. Or you could say, look, that's the same as y equals 2x minus 4. I think that's 2x minus 7. All right, so we can use our table. We got a minute left. That's enough time for our cool down. Oh, 10 seconds. That's plenty of time. You can spot this one almost instantly, I think. Second derivative of f of g of x. A, B, C, D, or E? E. Now, what's the thing? First derivative, you're going to have two terms. So you're going to have a product rule. So your answer better have two pieces to it. So E was kind of the giveaway. It had two parts.